Come walk with us.
A typical urban commute requires navigating loads of uncertainty. Uneven pavements, scooters left across sidewalks, construction detours, low-hanging branches, and more. For sighted individuals, these obstacles are navigated almost without thought. But for people with visual impairments, those same uncertainties carry much greater risks. In fact, 63% of visually impaired people report being injured in urban environments. While tools exist to guide people from point A to point B, and mobility aids like the white cane provide essential feedback about the immediate surroundings, there remains a gap in independent navigation to unfamiliar places. Through conversations with stakeholders, we heard a consistent theme. Unpredictability changes how freely people move. And for many, exploring new environments requires additional time, trial and error, or even sighted guidance. And for some, this uncertainty is high enough to avoid unfamiliar routes altogether.
To aid blind and visually impaired individuals, we introduced Sidewalk Sidekick. Sidewalk Sidekick aims to provide an integrated platform to assist individuals in navigating outdoor urban environments. Sidewalk Sidekick is a quadrupedal robotic platform able to replicate the feel of a sighted guide dog, but with intuitive control in the hands of the user.
The robot is able to guide the user to new locations with integrated GPS. Proprioceptive and auditory feedback from the robot provide the user with environmental insights, allowing for smooth traversal over rough terrains and callouts for sudden obstacles. The front-facing RGB camera uses real-time computer vision to classify path-obstructing obstacles to inform the user, while integrated stereo depth cameras and the mounted LiDAR are used to detect and avoid these obstacles. Additionally, the robot is multimodal to adapt to any sort of urban environment. With the driving mode, wheels are used to smoothly match ambulatory speeds on everyday paths such as flat roads and walking trails. For more uneven or cracked terrain, the traversal mode utilizes the legged architecture. This can even be used for guidance over elevated surfaces such as curbs and stairs. The robot utilizes impedance control, turning its own legs into a springy suspension system using a motor control scheme. This allows the robot to smoothly drive over smooth obstacles and provide intuitive proprioception to the user.
An integrated rigid handle is used to control the robot. This handle is designed with 4 tactile buttons. While raised surfaces, distinguishable shapes, and tactile bumps are the primary indicators of button function, the buttons are also brightly colored to signify robot intent for medium-blind individuals. The triangular green button is to start the robot. The red circular button functions to stop the robot. The yellow X allows the user to obtain a description of their surroundings through Bluetooth open-eared headsets.
We're routing around a e-scooter.
And the blue square enables the user to command the robot to make turns, lead to locations, or even ask the route about progress.
You have reached the end of a straight path. Do you want to turn left or right?
Turn left.
Turning left.
This communication is tailored to the needs of the individual through a user preference control tab, so users can receive the right amount of information about their environment regarding hazards and surroundings. Sidewalk Sidekick provides an integrated platform that combines the autonomy and control from a traditional white cane with guided navigation abilities of a sighted guide. While guide dogs take 2 years and over $50,000 to train, our solution costs roughly $4,000 to build, increasing accessibility to users in need. Sidewalk Sidekick benefits in being able to create new paths based on the changing needs of the user and variability of their environment. For a safer stride, choose Sidewalk Sidekick.